Hi guys, this is Tir Doshi and this is a channel only for lead code problems and this channel is not meant for money making or anything. All I want to do through this channel is teach and have fun teaching for the love of teaching and have fun problem solving. So this channel will not, focus a lot on code. It will focus a part of it on code, but here the idea is to understand the logic, the big picture of every problem that we solve on this channel. And yeah, I mean, we solve it. So the first problem that we are going to take as next permutation. And before I go into the problem, it's very important for us to understand what exactly next permutation is. Uh, so yeah, it's recording. So I was just checking. Anyways, so what exactly a next permutation of a number is? So when I talk about next permutation of a number, it's simply the number. It is simply the number that comes after the number using the same combination of numbers. So for example, if you have a 1, 2, 3, it means that it's 123. The next permutation would be 132 of these numbers. Why? It's a simple logic that we derived here. 3, 2, and a 1. What I do, I simply check which number is the first number that is lesser than 3. I swap it. As simple as that. Which number is lesser than 5? I swap the first number here. It's here. So 151. So these two examples are not really enough for us to understand things. What we want is a broader example. So we have this example 5826974. What should be the next permutation of this particular example? Okay, it's important to walk through this example. What should be the next permutation? If I observe it, and let's just solve it in our mind first. Okay, how will I solve it? 582 remains the same. Now 6,974. Can I change really 6,974? Why did I keep the 582? Because these are really big numbers, and it's 58 lakhs 26,974. So I want to check if there was a next permutation of numbers, it definitely has to be somewhere. The changes must be made in the units, tens, hundreds place first if there was a next permutation. So anyways, we'll get to that. 582, 6,000. Now look at this, 6,974. So when I look at the 6,974, all I see is a simple thing. Simple thing. Okay. 6,000. Let's just look at 6,974 as of now. So 9 is here, 7 is here, 4 is here. All of these are in descending order. So when I just look at 6,974, these numbers are in descending order. So can I keep 6 here and have any other combination over here that would be a greater number than 6,974? Definitely not. That means that the next permutation of 6,974 in our mind would have been 7,900, 7,469 with these numbers. So that's what I really want to do, So basically, what is the element of interest here is it's the 6 that is the element of interest in this example. So this 6 is my element of interest. How do I deal with this 6? What exactly should I do to change this 6 to a 7? One thing, and then do something related to that. The idea here is you have this element of interest. So you can get there using some pointers. Let's not think about the implementation part. You just got there to 6. Now, if I find the immediate number that is greater than 6 and to the right of 6 is going to be 7. So I definitely know the next number will start from 7. So I swap that. I swap 7 and a 6. So 7 is here, 6 is here. Now what do I do? 7 here, 6 here. Now what is the logic that I need to follow now? The logic I need to follow is 7964. So this is the number that I've got. Okay. So interesting, 7964. If I start with 7964, if I have a 7964, or if I say that if I start with 7000, I put 3 elements, either 9, 6, or 4 at every position. What should be the first number that should be made? 469 should be made, right? Observe that this 7964 is having 964, which is in descending order. So that means that's the last combination, that's the last permutation that can be made from a 7, from the number starting at 7. So that's the last combination that can be made. So the first combination that can be made would be just the reverse of that. So I just do the reverse of that. So 974, I swap. After swapping, I have 469. So after swapping, I have 964 here. This is in reverse order, so of what I really want. So I just reverse this part. So 9, 6, and 4 should be reversed. You get a 4, 6, and a 9. As simple as that. Isn't it beautiful? It's a very interesting problem to solve. So this is my real answer, and you have this. So what should be the structure? Understand the structure. The structure is this. First thing that we do is find what is the element of interest here. So the element of interest in this example was 6. Why was it 6? Because that was the first number that was breaking the streak of descending numbers from behind. So that became my element of interest. So it meant that if the next permutation, then I know is the immediate greater from this side. Okay, it's the immediate greater, and that is 7 here. So I swap with that 7. I get this guy. My eyes tell you 964. I know that this, when swap happens, this will always happen such that the point from I plus 1 to the last element would always be a descending array. So I can reverse it to get an ascending array. So how do I reverse it? So that is the logic here. Let's walk through the code now. Okay. When I walk through the code, the first thing that I see is, okay, I'll initialize my I to the second last number. Okay. So in that example, I am just removing this because it's getting a little confusing for me also. Okay, my I is pointing here to the second last number. My I is greater than 0, and I will check 7 and 4. Is 7 greater than 4? Yes, it is greater than 4. So you move your pointer behind. 9 and 7 you check. Is it greater than 4? Okay, is it greater than 9? Is 7 greater than 9? Yes, it's greater than 9. Oops. Is 9 greater than 7? I meant, okay. 9 greater than 7? Yes, it's greater than 7. So you move the pointer behind, and finally you come out of the loop at this point, because 6 is not greater than 9. Okay. So this is what the while loop is doing. Now when I go down, once I know that my pointer, I finally found the 6. I know that I've found the 6. I check these numbers, okay, and in these numbers I need to swap the next greater element. So what I do, I keep a pointer here, one pointer here. I will check if this pointer, okay, 6 is greater than 4 here. So you move that particular pointer j, call it j. You move this guy, this pointer here. So you move that pointer behind, that is j minus minus. Then you compare the 6 and 7. So if 6 is smaller than 7, I know that that's the first element that needs to be swapped. So I swap it. So this 7 comes here, 9 comes here, and 6 comes here. So that's what this loop is doing. And the swap is also done. Okay. Once the swap is done, I is still pointing here. Okay. J was pointing somewhere. Maybe J was pointing here at that point. So I will change I to I plus 1. So it points here. And J will be changed to the last element. And I reverse it. How do I reverse it? It is simply, if I want to reverse any particular number or array, if you have 1, 2, 3, 4, I want to reverse this guy. So I start one pointer here, one pointer here, swap the elements. You have 4 here, 1 here. Then increment your I here, decrement your j here, swap them 3 and 2. Now if I is lesser than j, no, it's I is not lesser than j, I will come out of that loop. So 4, 3, 2, 1 would be my reversed string in that example. So I have just implemented the same algorithm. I is this guy, j is this guy, and I keep on swapping until I reverse it, or until your I is, your j, I starts incrementing, j starts decrementing. At some point, I crosses j, and at that particular point, the loop falls and the number is reversed. So that's how I generally reverse. So that is, yeah, so that is giving you the implementation, and we always remember the structure of the problem. So I think this is done. So that's it for today, guys. If you like this video, please like, comment, and subscribe to this channel. And yeah, have fun, learn, and yep, that's it.